Okay, we are in 10-3, which is multiplying rational expressions, and you can use what you know about simplifying rational expressions when you multiply them. Step 1, we're going to factor the numerator and the denominator in both expressions. Then we'll cancel out any common factors and simplify if needed. Here's our first example. We're being asked to multiply and to state any restrictions in the domain. Remember, that means that we can't have 0 in the denominator for either one of these factors. So we'll start by factoring right here. We have 2x squared plus 7x plus 3, and that is the leading coefficient is not 1, so we're going to use the A&M method. So I have 2x plus 1 and x plus 3. And the denominator here is just x minus 4. And we're going to multiply that. And over here we have x squared minus 16, so that is x minus 4 times x plus 4. It's the difference of two squares. Here we have factors of 15 that add up to 8. Because our leading coefficient is 1, we can use the shorter method. That's x plus 5 times x plus 3. And this is a good time to look at our rational expression to see what number we cannot have in the denominator to restrict the domain. We know here x cannot be 4 because that would give us 0. Here x cannot be negative 5, and right here x cannot be negative 3. And now we'll go back and we'll simplify by canceling out anything common. Anything divided by itself, remember, is 1, so I can simplify those. And that leaves us with 2x plus 1 times x plus 4. And that's all divided by x plus 5. And there's our domain restriction, cannot equal those numbers. And there's our simplified polynomial, our rational expression. Okay, for number 2, again we're going to be factoring. So right here, this is the difference of two squares, which is a plus 2 times a minus 2. Right here, this is also the difference of two squares. They're both perfect squares. Right here, that is already simplified. I'm just going to put it in parentheses. And then to our denominator here, we can take out an a. That's common. Right, again, a good time here to say what values a cannot be equal to. Right here, we cannot have negative 1. Here you cannot have 1. Right here it cannot be 0, and then right here it cannot be negative 2. Alright, now let's cancel out what we can. We have a plus 2 and a plus 2, and because one's in the numerator, one in the denominator, that's what allows us to cancel them, leaving us with a minus 2 in the numerator, and in the denominator is a minus 1, and then we have an a right here.